We're live.
We're here. Are you taking this? Hey, go ahead.
You go.
Hey, welcome to the show. As you can tell, it is a mess, an absolute mess of a week. And today we're going to break down some big Microsoft zero-day patches. We're going to talk about the service mesh wars, and I'm going to be going through a little bit of Prometheus Grafana demo for you guys. So I'm Mike Foster. It's my partner in crime. And welcome to
We're never going to get the intro right. Never going to happen. Yeah, the reason we screwed that up is, it's on brand. We screwed that up because we were talking about a tagline. Do we need a tagline? I've got a visual newsletter for an impatient world and all sorts of stupid stuff like this. And then I forgot what our original intro was.
Happens to
Doesn't matter. Doesn't matter. If I'll do your bit, you did my bit. If you're watching on YouTube, please subscribe, tell your friends, share the show on all your wonderful social networks like Reddit. If you're on Twitch, if you're Twitch live, hi, how are you doing? Please follow us there as well.
Yeah, we got an awesome show. You wouldn't know it by the intro, but we do have a really good show for you guys.
Yeah.
We've been talking a little bit about service mesh and supply chain and dependencies in the last couple of shows. So I think it's fitting that we kick off the show with a great article about service mesh wars and why some people are actually moving back away from it. And they've been trying to implement it for a couple of years now, and it's goodbye. So Steve, do you have any experience with service mesh in production, especially? I mean, it's probably only a handful of people at this point that use it in production, but
so one of my formative memories of Istio is when we first met talking about service mesh and how few people actually successfully implement Istio. I don't have to do it myself. I just find Istio gets in the way of my everyday goings on with discussions about security, and there's always somebody there who has been saddled with Istio. There's always a poor engineer in the discussion that says, does it network security? Does it support Istio? This is always a question, and it's like, wow. Tell me about your pain. So that's it. This is, and the number of people who it never seems to succeed. So for me, this was all theory. So do you have actual hands-on Istio?
Not in production, but in terms of implementation, a little bit, yeah. And this article actually summarizes it pretty well in terms of what people are using it for, and it really is, traffic monitoring between microservices and adding MTLS. MTLS being the biggest one, because when Kubernetes first came out, a lot of companies didn't want to do it because they were worried about services and how the applications would interact, and they wanted MTLS. And it was one way of achieving that. Nowadays, you have different ingress controllers that do those basic functions that you need, and you don't need the sidecar architecture, right? Citrix has an ingress control that acts sort of like Istio, but instead of having sidecar, you just have this sort of proxy on every single host that acts as the go-between, right? So you don't need to have the sidecar architecture to achieve the same output. And that being said, if you are to the point where you have like one service that needs MTLS, you should put that on maybe a separate node or something like that. Like it actually might make more sense to separate that off and manage it as its own unique security entity, right? So it's like, that's what we need to be secure. So yeah, anyways, they summarize it pretty succinctly. It's very hard to scale. Really is only reliable for HTTP traffic right now. And there's a couple other things that they talk about that would have made it easier. The complexity is massive. Like, I mean, you're talking about onboarding a team to Kubernetes and Docker and containers and creating new workflows. And then now you need to know CRDs, sidecar architecture, traffic monitoring and tracing and distributed tracing, because tracing is somewhat different now with microservices. It's just a massive overhaul, and it's pretty heavy, right? We're talking, an extra couple milliseconds every hop. And you think about it, it's really only useful when your proxies and your ingress and your controllers don't know where your other microservices are. And so you end up getting rerouted to a host when you actually could have just gone right next door to the other service, right? If that isn't a case and you're not at that scale, you probably aren't going to need that. So you're talking about an extra, I think it was 6 milliseconds as of 2 years ago for the extra hop for every connection. So yeah, there's a lot there.
Performance centric. Like I've had questions about when we're implementing security tooling that uses agents or even sidecars or injection of some sort. What's the performance? We're really concerned about performance. Is there a performance hit associated with security? It's like, well, yeah, everything has a performance hit. And then they're like, all right, well, talk to Bob. He's implementing Istio. It's like, do you care about performance or do you not?
Mm-hmm.
I saw nobody watches our show at that scale. I saw a live thing in London about a year and a half ago with Craig McLuckie, and he at the very beginning of it said, "We're not recording this, right?" And then he started to rip into everything he doesn't like, and Istio was one of them. He's like, "Just use Linkerd. Like, it's just too much, trying to do too much with one thing." And so it was quite funny to see that that's what this guy gets to the bottom. He's like, I just use Linkerd. It does all the things I want. It's so much easier. It's in the CNCF.
And it was Istio also, the architecture and the way the application is built. I believe it originally came from Google, and it was sort of built more for like VMs and containers, sort of as a way of visualizing everything. And it is a lot heavier than something like Linkerd. Linkerd was built specifically for Kubernetes. And I know that Google and a bunch of the different creators have done a lot to simplify Istio. When Istio first came out, there was, it wasn't a single, because Istio itself has sort of a control plane, right? And that was like 3 or 4 services 2 or 3 years ago. And then there was this big 1.15 or 1.5 release where they brought everything together. And I looked at Istio 3 months later, and I was like, wow, this whole application's changed. Like how I navigate the application's changed. And those big, unless you have somebody dedicated to following these things every time, like, I mean, you're talking breaking changes on some sort of new product. So that's never going to make it into production unless you have a full team following it, right? Linkerd, really simple. I have a good friend, Jason Morgan, over there that's working with them, and there's some pretty cool stuff going on. So maybe we should do. I spent a whole bunch of time doing VMs and Prometheus and Grafana. Maybe it's worthwhile setting up a Linkerd on that cluster and seeing how easy it is, and then I can come back with a newfound appreciation for what they all do.
It's a good point, actually. I just found out today, because of this article and because I was playing with my Pis again, that you can put Linkerd on the Pi on K3s.
That's pretty impressive.
I could do that. Yeah, because they have ARM support as of like last November or something like that. So I'm going to try that. Maybe I'll have a demo. Hey, how about that? Let's put our let's shut up and do something.
I was going to say, what we should do is you should do Linkerd and I'll do Istio, because I think I have a little bit more of a beastly server. So you could probably take Istio, and then we come back with our notes about what's changed. And
I don't even, let's do that. Let's do a head-to-head of Linkerd versus Istio.
Competition. Who can make the most stable service mesh setup at home?
Challenge accepted. No, what's going to happen is we're going to get to that show, and I'll have set Linkerd up like 3 weeks ago, and you'll still be working on Istio.
I will say the one place I've seen Istio get it right, though, is Google. Which obviously makes sense. Their integration for Istio in terms of Anthos, they do a pretty good job. It's my one. So if you want tips, go to those guys.
There you go. All right. Well, they have some insider knowledge.
No kidding.
If you want, shall we dive? You got why we hash passwords.
Yeah, why we hash
that? Why?
Sure.
Well,
yeah.
Boom.
Yeah. So I came across this article. I thought it was pretty interesting, and it just a quick note about what the difference is: plain text, ciphertext, hash value, and why these things should be hashed and why you should do it at scale. And they talk about a couple different break-ins, and they actually talk about salts. And really, if you're hashing a password, I don't know if you can scroll down to some of the images there, Steve. If you're hashing the password, so this is like a ciphertext, right? So you have a ciphertext, it's going to compare against the password, but then all you need to do is reproduce one password, and you have the key to unlock all the other passwords on the database, right? Because it's just that one key, and you have to make sure the key's saved, and likely your system administrator has access to that key. So it's really, really, it's vulnerable if you can basically just exfiltrate all the database stuff and then figure out the cipher. You have access to millions of passwords, right? And sort of it's the same thing for hash values to a certain extent, right? If the hash value is always going to be the same, it might be a little bit more complicated, but if you scroll down a little bit further, it'll show like, you can have simple passwords that still have sort of the same length and hash.
Well, these two are the same.
Yeah, that's just the username, but if you scroll down, it'll be like, password 123 right there. So the hash function itself is
got it.
And so the salted hashing is just more of a way of introducing some variety into the password process. So you don't there's not a single hash. Now you have multiple different sort of salts, they want to call it, that will change the password on the other end. So it's an interesting way. And really what this helps to achieve is just it makes it time consuming for somebody who gets access to an entire database. Right.
Yeah. Now, it's also like if you go to just to add on that, like there are huge databases of every possible hashing mechanism of all commonly used passwords. So if if someone cracks a database full of passwords, it gets up on the dark net, someone buys it, and there's no salt, then it's just a lookup to figure out what your password is. That's the thing. The reason I was confused about the two being the same is that some of the older methods as well, like, had the possibility for collisions where you could have two totally different words that ended up with the same hash, which was bad.
Yeah, no kidding. And this is actually going to lead into one of our other articles coming up that are pretty interesting. So worthwhile read if you don't know a lot about hashing and encryption. I mean, I remember when we talk about Kubernetes secrets, and I used to do demos and go to customers, and they'd be like, Kubernetes secrets, and then it was base 64 encoding, right? Not encryption. What? Right?
Yeah.
So
yeah. People don't. It's funny. The people don't understand that base 64 was originally designed just so you could print it out on the screen, kind of thing. Like it's not, or you could. Well, wait. It was never meant to be encryption. There's a really good thing down here about derivation functions, key derivation functions, where the entire point of that is that if you log in and it takes 5 seconds to compute the hash, to compare the hash with the salt, etc., that's not really something you do a lot. You log in, it takes 5 seconds, you're like, whatever. But if you start instituting some kind of brute force attack, it would take more 5-second attempts than, I think they said, like more than any human being's entire life to come even close. So that's another really quite clever thing. And there's even a nice little Python function here you can run just to play with it. So if you want to see like how long, I think it takes, was it 3 seconds, 3 seconds to calculate the hash for the word password. So you can actually, if you want to play with it, probably should have done that. Paste that in, run it on like something longer, and then see like how that number changes. And then it sounds basic, and someone in the comments is going to say quantum is going to screw all that up, but whatever. This is great. It's pretty cool, pretty thorough.
Yeah, that's funny. Very true. All right, let's we got some breaking internet news / something broke the internet.
Yeah,
so,
fast Fastly. Who hands up if you felt the Fastly internet being down thing? That made a difference. Where is it?
Yeah, Amazon, Reddit, half of the web, Twitch. I think got hit with it. Oh yeah, there it is. Reddit, Spotify, eBay, Twitch. Now it was only down for like 1 hour. They got it up really, really quickly. People were saying that it was a hack. I think somebody just messed up and they rolled back pretty quickly, and so I think we're okay.
So there's a good article here with what off from their site.
Oh, look at that! There you go.
What happened? They changed the software. Somebody submitted a legit customer configuration change with specific circumstances that they're obviously not telling you what they are, broking 85% of the network. I so want to know what that was.
Yeah.
So there it is. Onset of global disruption. You never want to have that.
Identified within 1 minute, status post within 10 minutes, and then rolled back, and impacted services recovered in 45 minutes. So an hour basically between the disruption, and that's a really, really good response team.
That's amazing.
Right. Yeah. What's interesting too is because nobody knew about Fastly and this broke, the stock price jumped like $10. Because then it's like, oh, you realize the entire internet. Not the entire internet, but a significant amount, right? You look at Cloudflare and Fastly and those services, people aren't aware of them, but internet is held up by a lot of moving pieces. So it was
that's pretty funny, man. You know, in the end, it's probably just a dude at the top. Some CFO is like, what if we just turn it off for like 5 minutes? Think we'll get noticed?
Yeah. You got to wonder what those SLAs and uptime agreements are, because holy crap, you're down for an hour and you're breaking some of the biggest websites.
Yeah.
That's some serious coin that's being lost, right?
I'm going to answer a question in the chat.
Crazy.
Hold on, YouTube. There we go.
Oh, hey.
We have a good question from one of our fans, which was, let me just pop it up. Do you guys know GitHub right for all the cool stuff? See, thanks. He thinks we do cool stuff on the podcast. We're thinking about a newsletter and all sorts of stuff, but at the moment we've reorganized the way we do subjects, and I'm putting all the links that we do into the YouTube notes at the very least, so you can click through and see if you're watching this on YouTube, or after the fact. But we're looking to get organized there. All right.
Let you follow along as we move into some malware.
Right. Okie dokie.
Yeah, we got a couple of Microsoft things coming up. So Windows container malware. That's mine.
I just added you. Well, sneak preview.
Yeah.
Windows containers malware, like first known malware targeting Windows containers to compromise cloud environments. This is from Unit 42. Sorta my new employer. But it's what do you think about, I think I've asked you this before. Whenever Windows containers comes up, I don't know why I feel like you got it coming. When things go wrong with them, or there's a bug in Kubernetes. That was what we had a few weeks back. It's complicated, but congratulations, Windows containers, on your first
luckily I have never had to do any sort of production work with Windows containers. So I don't want to comment. I understand that there's a lot of, let's say, older organizations that I've worked with who have written, a lot of their applications on .NET and things like that. So they want to get in, like you want to take advantage of the new workflows that are available to you nowadays, and you want to take advantage of containers. So I get it. But yeah, it's almost kind of at the point where if you're still writing in those old architectures, you might want to move the architecture first, right? Try to get onto .NET Core or something like that. Start trying to figure out how to run it in Linux, and it's there's just a lot more options than just trying to wedge something in. But I also don't want to speak because I know I'm missing a ton of use cases. If anybody else knows about those, it's and honestly the other big thing is like AD, Active Directory. Getting a business on that thing that's a beast, right?
Yeah.
And that's how they get you and rope you in there. But
so they get you. Vendor lock-in. I get it because I know a bunch of .NET C# folks, and then everyone moves to containers and cloud, and they're like, our entire coding staff is on one stack that is heavily Windows dependent. So they're like, oh crap, guess we'll do it that way. Mm-hmm. But having now worked for 2 different Kubernetes and container security people, when you walk into people who are asking for help and you go, yeah, we're here. Yeah, it's all Windows containers. All right, see ya. Because there's just not a lot of security solutions that accommodate that. So it's like you're in trouble right from the word go in that space for many reasons, including security.
Yeah, it's true. Not a lot of companies want to support that use case, especially because it is so niche. And it's like the anti-pattern stuff, right? How much do you support people when they come to you and say, hey, I need to do this? It's like, no, you shouldn't, right? Is it worthwhile? Do you support something like that just for the money? Somebody else might do it. You just have to have that conversation.
Indeed. All right. So keeping on a theme.
Yeah, on the MS theme. We got 6 0 days that Microsoft's patched.
It is Patch Tuesday. There we go. June's Patch Tuesday addresses this is grabs on security. Just 49 security holes. And 6 0 days. Look at that.
Yeah, we had VMware going for the high score 2 weeks ago, and then we got Microsoft. How many security holes they patching?
This is
and it goes across a ton of versions too. So it was some underlying library, right, for the operating system. SharePoint had a critical one. Adobe, it is interesting to see because of the speed of development now, thanks to just DevOps and containers, like you're just going to get more and more security flaws. We showed a graph, I think, a month ago about that, right? Literally an exponential graph in terms of security flaws that are being seen. The other thing that you're starting to notice is because open source and open source code seems to be a little bit more, it is more prevalent nowadays. Those things have to be reported, right? Like, do I think that Google had a bunch of 0 days that they figured out internally? And I don't want to pick on Google. I'm just saying over the last 10 years, of course, they don't necessarily need to report it to the public all the time, right? Small outages that get fixed within 15 minutes. If nobody notices, like they're not going to email everybody, right?
It heavily depends on regulation. I think we had this conversation on an article recently where it's like, used to be you didn't have to do anything, but now under GDPR, even if you don't know whether there's a breach, if there was an opportunity for a breach based on something that was released into production, you have to disclose it.
Mm-hmm.
So, but in the States, if you don't have European customers, under the carpet.
Is that at the actual wording? An opportunity for a breach?
That's not the actual wording. I'm not quoting it.
Okay.
I know that is it. It's been a while. It's been 4 years since, but I mean, in 2017, I wrote an article that summarized the things in GDPR you need to know. And I think it's on the GDPR website. So I'll go dig out my article and read it.
Yeah,
because I can't remember.
Bring it in the next week.
Yeah, that is a thing, though. Yeah, that's why it seems, certainly over here, why there's just so many more announcements of what it says. Oh, data breach, and you go look at it, and it's like, no, it isn't. It's a researcher, or it was like, there's no data released. There's no attacker. There's nothing, but they have to say it now.
Mm-hmm.
So it just makes it seem way scarier now than it used to be, simply because more people have to say things.
It's equivalent to the Sunshine Law in Florida. Do you ever realize why there's always Florida man memes? Have you guys heard of this?
No.
This might be a North American thing, but Florida gets a bad rap because there's always these crazy Florida stories. But Florida has a law that anytime somebody gets charged with a crime, that crime has to be made public. The charge is public. Whereas in a lot of places, the charge isn't made public until you're prosecuted or something like that. So the issue with that is, because of the Sunshine Law, a lot of people get charged for things that might not necessarily be accurate or be overstated, and the media can just take it and run with it with the headshot.
Oh, yeah. So if you live in Florida, and
Yeah, it's
Anybody,
just one of
I want
those.
to get you.
Yeah, and so there's a good and a bad with that law. Is like obviously everything's made public, so oh, so and so is getting charged with some ridiculous crime. But then the downfall is you get the Florida man memes. Could be a good thing, but like Florida's the crazy place in the U.S. because of it, and it's just because of all the articles about it. Anyways, sidetracked. All right, next. Well, this is kind of a rehash, right? We're moving back to, hey, that big 9.8 CVE, you should probably fix it.
It's funny. I feel like we said this when we showed this vulnerability. We're like, you're not messing around. That's the highest number you can have. It's active. And I went on Shodan and went, look, there's only I think they said there was like 2,900 visible versions of this. And then I searched live on the show and found 2,600. And I was like, oh, good. 300 people have fixed it. Whoopity-doo. Oh, I should have had it up again. I could have searched. But anyway, see if the number's gone down or not. But yeah, it's happening. People are using it.
Code execution, no authentication required. Into your vCenter that has basically admin access into all your virtual machines. So
yeah, it's under active exploitation. That's like, this isn't just a theoretical vulnerability. It's a super, like, baddies and bored teenagers are thrilled with this one. So you don't have to be a genius. Anyway.
Yeah, I mean, this probably could go under our next section, but we're just going to get into it. So good segue. Yeah, and under the WTF section, you put this in, so I feel like you're the best person to tell the story about Brendan Gregg's.
Oh yeah, cool. All right, so this Brendan Gregg is famous for eBPF research. He's kind of like the guy, right? 90% of the tools out there that have made it big are his. He does have a very, like, I don't know, 90s looking blog, but it released on the 4th. He talked about back in 2005, he was writing a series of tools called dtrace, and he was really excited about it. And so he started making dtrace toolkit, but it didn't quite work because he didn't have access to the kernel. So he was just fiddling with it. He had a bunch of half-baked stuff in his Git. And then this dude from Sun Microsystems comes in, like that with the meeting. There's a lot of just writing, and then starts selling him like this amazing toolkit. And he's like, oh, thank goodness, because I really tried to make this work myself. Sun obviously having access to the kernel could make it work. And they're like, oh yeah, great, sure. And he wanted to see it. And then you can see they gave him the source code, and he's like, hold on here. This is my script. Like, he's looking at, like when you write code and you look at code, it's got your style. It's like, you're like, this is mine. And so he started searching to see if his names were, because he always brands the header files the same. And he's like, no, they stripped out all his headers, all his licensing, which was open source, and they added their own. And he's just like, there's another, he's Australian. So he's like, anyway, they confronted them on the spot about it. He just thought it's ridiculous. So I just thought Sun Microsystems tries to sell him his own software rebranded. It was a different time in 2005.
Yeah,
the ethics around open source perhaps were a little flippy floppy back then, and now it's all good. But it's funny that I guess this is the first time he's written about it. Maybe he just wanted to distance himself from, didn't want to like besmirch Sun Microsystems at the time, but now it's okay to say it because it's so far in the past. But he just go on to say that loads of people have since then taken his work and incorporated them and credited him and licensed, and it's all good, right? But yeah, it's just very funny. That is a good story.
Yeah, Apple uses his source code. That's pretty cool.
Yeah.
That's
can you imagine? What are the odds?
Though? And he knew it right away too.
Yeah. Just looking at like, this is like they said, there's even like the names of
like the variable names and stuff like that. They didn't change.
No, like even some of the executable names were the same.
Oh,
like, yeah, because he said he wrote one called socketsnoop.d, And that's such a strange thing to, but it's like all the names are the same. Like they didn't do anything except strip out the headers. So it's like, come on. Even when I was in university and I stole someone else's program, I was a little bit more thorough than that. Right?
Yeah, fair enough. Yeah, they don't have, they need like the plagiarism checkers, but for code now.
They must have that.
I don't know.
They must. That must be a thing.
I've been out of university for too long. It's not needed.
Tell me about it.
Yeah. All right. On to some next. This honestly kind of WTF, but also kind of awesome, right?
It's amazing.
So the police created an elaborate, secure mobile app platform and arrested a ton of people.
Like a ton. What does it say? How many? 800 suspected criminals worldwide after being tricked into using an FBI app called Anom. If you go through, there's loads of articles about it where they actually had there was a guy who was going to go to prison, but he was a bit of a techie at making apps. He'd done something bad, obviously, and they went, okay, well, how about a lighter sentence? They do this app for us that is kind of like Signal or Keybase or something that allows people to super encrypted conversations. And then they went beyond that and they made like phones that they said were really encrypted. And you had to do, I don't know if this article or not, but there's somewhere where the criminals thought they had to type a code into calculator, like open up calculator.
It's right there. You had to know a criminal to get a hold of one of these customized phones. The phones couldn't ring or email. You could only communicate with someone on the same platform. That was how they set these devices up.
Super limited. So it's like a BlackBerry, but a really old BlackBerry.
Yeah.
But it's and so that its primitiveness probably made it seem more secure.
Mm-hmm.
And so they're doing all this under the hood. Under the hood, it's just sending the whole thing to the police. And they're like, I wonder, like, when that started working, it's like I don't know, it's almost like a movie Black Klansman or something. They're just like, what? They're just, I cannot believe this is actually working. Like, when do we stop? Because we don't want people to know this is how we did it because it's too good.
Yeah, I feel like it's almost like the invitation game where you crack the code and you're in, but then it's like, when do you have to play the game to make sure that you don't just arrest people and they figure it out. So it's, I think also the coordination to get that many suspects and it not leak that this was, basically there's a backdoor into all this stuff is pretty impressive.
Yeah. So the
WTF for stupid criminals.
I don't know that they're that stupid. It was pretty, let's give the police some credit. Sort of closing note on that one is that the reason they all kind of got into it is because there was this Australia again, oddly, fugitive drug trafficker guy who's the one who originally got tricked into introducing the entire system into the criminals, right? And we have a spam comment. So, and this person is now called the Facebook gangster. It's like he's in Turkey to evade arrest, and the police and the criminals, everyone's trying to get him. And the last comment the police said was, he should just hand himself into us because we're not even trying to find him. We'll just let the criminals do it. It's just like, oh crap.
Checks out.
Yeah, who knows? He's in trouble.
Yeah. Hey, if you guys want to become famous, hit up MBT.
Whatever that
911. Just spam stuff. The bots are here. I gotta put some walls up now.
Damn.
That's a big WTF. All right. So ending on that, the WTF spam comments. That's a great article. We're moving into the
All right, synopsis. Another one of my exes acquires Code DX to extend application security portfolio. So if you don't know, do you know Code DX? Actually, let me ask you.
I don't. I'm unaware of Code DX. Do you know?
It's like a well, I could just bring it up. Well, so let me explain Synopsys, and then it'll seem weird when I explain CodeDX. Synopsys, 2014. When I was there, then they created their software integrity group. They're actually like electronics design automation company originally, and then they decided we want to be security now, so they acquired Coverity, Black Duck, Codenomicon, a product called Seeker, a whole bunch to try and make this sort of big platform-y thing. Mm-hmm. And that was pretty cool. And then they went to launch this thing called Polaris, which was and that was while I was still there, which was meant to be like a SaaS version of all of this kind of integrated, which you could probably already think if you acquire like 4, 5, 6 different tools, and then you try and amalgamate that into a platform as SaaS, where none of these were, some were SaaS, some weren't. That's a pretty epic undertaking to attempt to do. I don't know how successful that was, but let me just slide that in if that works. This is sort of feels like what they were trying to do. It's like, I don't really, I felt like the thing they were trying to do with Polaris is kind of what CodeDX was. I feel like they were a little bit of a competitor. So it's like better developer experience for application security, and creating workflows and things like that. So I thought that's where they wanted to go. So my guess is that they worked out, this is really freaking hard. Let's just buy somebody who does a really good job of it already. So that's where I think their acquisition came from. So I think it'll be interesting to see what happens with CodeDX, and then the monster that kind of, I don't mean monster in a bad way, that Synopsys is in terms of a huge house of tools and consultancies in there. So probably good for CodeDX. The disappointing thing about this is they didn't say how much they paid for it.
Yeah, this is the first announcement, I'm guessing, right? So it's not done.
Yeah,
so we'll check in probably in a couple months. The other thing too about these acquisitions is you get the engineers, assuming that they don't leave, and you're paying them during the acquisition. So if they're having trouble integrating or building a specific platform and somebody does it, you are getting the IP, you're getting the talent too, right?
Yeah.
You can't underestimate that aspect to it.
Totally. I think it's pretty cool. And they might be getting a developer community along with it as well. Like if CodeDX has done a good job with that, then, you're getting a little positive vibe. Can't pay too much for that.
Cool. Yeah. Wish me some positive vibes as we move into some demo time. Are you ready? Because it's...
Does everybody know what time it is?
Dun-it.
Do you want to jam straight into yours, or do you want to talk about the Go thing?
Let's do Golang quick. I got time.
It's quick. It's super quick. All right. So Golang has a fuzzing library, dev.fuzz. If you're thinking that's weird, what is fuzzing, Steve? Fuzzing, this actually connects well. Synopsys had bought this company called Codenomicon. Codenomicon had a fuzz tool called Defensix. That tool was what found the Heartbleed bug back in 2012 or whatever it was. The first bug that had a logo. That was what they were most proud of. So it's a method of automating the manipulation of inputs. So that can be protocols, it can be APIs, it can be function calls, it can be anything. But it dismisses or gets rid of the problem that test-driven design has with, I know how this is going to work, I'm testing its functionality, how do I test the misuse or abuse cases? And so it's a way of automating that process, which is cool, because when they first launched it and they sort of gave it out for people to try, in a very short amount of time, I can't remember, it's here another article, they found something like 400 bugs in a very short, just by wrapping their testing in this sort of fuzz library. So if you're a Go person, it says right here, fuzzing can reach edge cases and code paths that previous testing couldn't, and is fantastic and valuable for finding security exploits and vulnerabilities. There we go. Kubernetes developers, get on it.
That's actually pretty cool. I'm gonna go try that out. I have a couple of Go programs. So neat. Very sweet.
All right. Shall we add you in?
Yeah. On my way.
All right. So popcorn.
Yeah. if you guys checked out last week's episode, you see that I just sort of gave a brief overview of Cockpit, how you can create a virtual machine and manage it on CentOS. So I have CentOS Stream running on my server. Now I have 4 physical nodes on the server. I'm only running on 2 right now because I'm experimenting with the other 2. So just bear with me. But as you can see, I have machine 0 here. I got my control plane. I have a monitoring specific VM, and I have worker 0 for Kubernetes. So control plane and worker are the 2 nodes, 2 virtual machines on the first node. And then on the second node over here, I have 2 workers that are beast workers. They have a ton of power on them. So just think 1 control plane, 3 workers. And then I have a specific monitoring machine. Now, we're going to look at Prometheus and Grafana and how I set it up in Kubernetes and how I also set it up on the virtual machines, and sort of if you want to run Prometheus and Grafana in Kubernetes, what the issue is with that, and if you want to run it on VMs, what some of the downfalls of that are as well. So as an intro, I felt like it's very useful to look at the architecture because there's a lot going on with just Prometheus alone, not even bringing Grafana or Alert Manager into it. So Prometheus and Prometheus Server, it's a big time series database, right? Every single metric, it's always CPU utilization at this specific time. And what you can do is you can say, hey, I want to get the CPU utilization every 2 seconds, 5 seconds, 10 seconds, 15 seconds. So one of the ways that you can sort of look at how you're managing your server is you can say, hey, maybe I don't need as much monitoring, or none of this stuff that I'm running, none of the workloads here are very important. I just need to know what the utilization is every minute. So you can kind of monitor your metrics that way. Biggest thing about the server is all we are doing is we're pulling into Prometheus. So Prometheus is, oh yeah, of course. That's better, Scorpio. So Prometheus here is basically your time series database, your HTTP server, and your retrieval. And what you're going to do is when you set up Prometheus, you're going to tell it, I want to do these jobs. I want to look at these specific nodes at this specific spot, and you'll be able to pull information from there. What that looks like in Prometheus in the UI is when I go to status and I go to targets, I can see the targets that I've pointed this Prometheus server at. This Prometheus server is on a VM. So it's looking at its own VM. Basically, Prometheus is monitoring the VM that it runs in, right? Which, let's just say you're scaling it. That's what you're going to do. You're going to look at all your VMs. Now, let's say I want to look at another VM. I don't need to run another Prometheus database, right? I just need to scrape that VM for its information. So what you would do is you install something like Node Exporter or some sort of, there's a couple different aspects or programs that you can look at, but really it's a program that scrapes for metrics and exposes it at an HTTP or HTTPS endpoint that Prometheus can go and scrape. But this one, I have Node Exporter running. So as you can see, it's like you have a job, you have an exporter, some sort of Prometheus target that works, that exposes information for Prometheus. Hopefully you're all with me so far. What I can do with that then is that's where all the information is stored, it's collected, it's formatted, and it's easily searchable, right? So when I come into Prometheus, I can look and I can see all of the different information that's available to me. And this is just the graph. So if I want to visualize it, if I want to look at it just in terms of metrics as to what it is, you can see there's a ton, and it's all specific requests with handlers and specific information that's there that you can query by. What changes is the targets that you hit and how you format it. So for example, this is a Prometheus database in Kubernetes, and it's looking at specific Kubernetes endpoints for information. So we're looking at authentication, container limits, container read writes, container memory cache, container working bytes, right? Specific to containers. Whereas if I'm in the node with Node Exporter, and I look at the graph, I have Go functions, but this is Node Exporter information that's being brought in, right? So node memory, node load, node file system, and they give you different metrics. And so you have to, when you're talking about Prometheus and especially your exporters and what you are exporting, you need to think, what do I want to look at? What do I want to format? And do I need all this information? Because you can actually configure your exporters to not give you all of this if you were worried about performance. So let's say you're on an edge situation and you want to monitor it, but you want to limit the amount of load. You can create and format your node exporter portion to only scrape and only expose specific information. So that's kind of how if you think of, if everybody's used FluentD and Fluent Bit, you think about that architecture. It's some sort of simple scrape and format at the source that goes and gets scraped by another formatting service and stored, and then queried by some sort of UI and visualization service looking in, right? If you think Elastic and Kibana, right? Right. So it's that sort of architecture, and it works really well for microservices. So all that out of the way, you have Prometheus. I have a Prometheus database in Kubernetes. I have a Prometheus database in VMs in my VM, and then I have the Grafana UIs. Now the Grafana UI I have running in a virtual machine, and I really, really do not like running Grafana in Kubernetes, even though it's great for service discovery. I prefer to run it in a VM. I prefer to have monitoring VMs set up, especially for something that's highly available. I would set up 2 VMs, 2 Prometheus databases that both just share information or scrape the same targets. And then if one VM goes down, you still have metrics, and that way they can actually monitor each other. Because if you only have one Grafana or one Prometheus database and you're sending alerts out and it goes down, your alerts are down. So you need 2 if you're going to go HA. Now, with that being said, Grafana makes it really easy. You come in to the homepage. Normally, if it's your first time, it'll say, "Hey, do you want to set up a data source? Do you want to, do whatever?" So there's data sources. There's a ton of different options. You can see I have Prometheus in Kubernetes, and I have my Prometheus with Node Exporter. And if I wanted to add a data source, there's a ton. So it's pretty awesome for all these formats and all these different things that you can do. One of my favorite now is Loki. Loki will take Kubernetes logs in and ingest them if you have Loki running in your Kubernetes cluster. The biggest thing to note about Grafana that I see, and I don't know, maybe not anymore, it's been a while, but Grafana isn't storing your information. Grafana is just visualizing your information, and it only stores for a certain amount of time, right? You can actually set Grafana and different dashboards to hold information and query specific information. Because let's say you set up Grafana and it's on a VM that only has a specific amount of space. Grafana will eventually run out of, it's not there, it's not your database, right? It just kind of pulls information from Prometheus and displays it, or pulls it from Loki and displays it. So just know that if you have some sort of logging solution like Loki and Grafana is pulling it in, that's not a good enough solution to manage your logs, especially over time, right? You need something like Elastic, just to get that out of the way. Now, one of the best thing too is because it's open source and everybody wants to join in. If you wanted to create a dashboard based off of Kubernetes metrics, I can go and I can import dashboards. So I can say, hey, I want to do a Kubernetes dashboard. I know this one is 10,000. I already have this one. I've downloaded it. So I'm going to go and take a look. Now, I download this dashboard and I found it's a very simple one. And you realize like there's no data here. So I fixed this one yesterday, but there's no data here. And so you're like, okay, well, what's going on? You go into edit. This has all been written. But we have this container CPU usage seconds total. Now, depending on what version of Node Exporter you have running in your cluster, sometimes these targets change and these specific things change. So it's one thing, let's say you have a process for setting up Node Exporter on Kubernetes and setting up Prometheus on Kubernetes and setting up Grafana. If the exporter changes and your target rules change, you might get a situation where it breaks your dashboard. The nice thing is you can just go over into, I believe this is the Kubernetes one. Yeah. So we want container CPU usage seconds total. You can go in and just do container CPU usage seconds total. So this should work. So something else is broken on this. Maybe it's probably machine CPU cores. So if we don't have Node Exporter on this, right, and our exporter is only looking in the Kubernetes cluster, we might not be able to have machine CPU cores total. Just depends on how you configure exporter. So you might have to go back and just say, hey, I want you to look at the nodes total. What was the metric again? CPU nodes total. We do CPU, node CPU. I don't know if I want guess seconds, but we could try that. Yeah, let's try that one. CPU seconds total. Oh, they want cores. I mean, I do know what the cores are. So really, this is just for being nice, but if I wanted to put that in, should work or not. All right, don't quote me on this one, but that's what I did for the other things. And
I missed what did you add there? I missed that.
I just added a 6. What's nice too is so everything's versioned. This is actually a perfect example. Everything's versioned here. I can discard the change. If I don't want to save it, I don't have to. This is all just working. So if I refresh it, that change is gone. So what's nice is like you can make a bunch of changes. I could screw this up, and what I can do is I can go to dashboard settings and I can look at versions, and it will show me the versions that I've used, and I can restore from previous dashboards. So really useful. You want to screw something up, or you just like, hey, go and destroy it. Okay, well, I'll just roll back directly in this dashboard, which is awesome. You can compare versions once you start clicking and going through this. And the reason why you can compare is because Grafana is built off of this JSON model, which gives you an entire dashboard in JSON. So if you're doing version control and you're doing it out of the cluster, you can just copy all of this directly on the host, pull it into your GitHub UI or GitHub if you want to get and change control your dashboards, and you can do that. I do know a couple of people who have used things like Ansible. Let's say you have these sort of, you can create variables for variable dashboards for namespaces. So you have kind of like a namespace dashboard that looks at all of your workloads in a specific namespace, tells you all of your limits, if there's any mounted file systems and things like that. And you make it so that anybody who has this instance can go download and use it in your, let's say, at work. And you just save this sort of base dashboard, give it to people if they want to go start up their own, or you can create user and guests in this, and then they can adjust. But one of the best things about this is if you're a DevOps role and you have a bunch of different teams, maybe you might say, hey, I want you to run, like maybe they have different test clusters. It's like, hey, I want this. This is like the default for monitoring for your spot. You can edit it and move it around, but this is the one default that you need to abide by. And then when you make changes, you can do, change control and actually get input from your other teams. So, because let's say you have a data science team that's working on Kubernetes, they're going to want to look at different metrics than, somebody who's running a web server, right? Data science might want to understand what the network IO is and what the read writes are, depending on if they're doing anything big data. So pretty cool aspect to it that you can just run everything through the JSON model. And if you're setting up Grafana on a VM, just with a specific install, these can just be configured as part of your setup. So if you're using like Ansible, or if you're using a VM in the cloud and you have a cloud init, you could basically put this file in at the specific config spot for Grafana, and it would work like that. And the same thing actually works for Prometheus, which is one of my favorite things too. These targets that you create and rules all are from basically a YAML file. So if you've looked at Prometheus in Kubernetes, you'll see that you can mount a config map in when you do it. And all it is it just creates basically the configuration for the Prometheus setup, because Prometheus is a Go binary, basically just runs anywhere. Config file, here you go. Here's the targets you need to look at. The massive benefit from running Prometheus in Kubernetes is service discovery, FYI. So node, let's say you want node exporter, or you want to look at kube metrics. Node exporter probably being the biggest one. You can run node exporter as a daemon set. So every single node that comes up in Kubernetes gets a node exporter. You only really need one Prometheus setup to query for kube metrics, because kube state metrics, the container that runs on the in Kubernetes, actually queries for your basic CPUs, your container seconds, and all that stuff. You can put node exporter on, and then you just, if you look at, let's see if I have it here. So if I have these targets, when these are being written, oh, look at that. When these are being written, you're not actually hard coding these IPs into the config. You're actually writing, like, let's say, there's going to be specific namespaces. It's looking at just Kubernetes.svc. whatever, right? So Kubernetes and the service discovery is just naturally going to take care of this, which is great. Versus if you're running Prometheus in a VM and you need to say, hey, I will need you to target this, node exporter on so-and-so host, you have to somewhat hard code that IP, or you have to have some process to input the IP into that config file that demonstrates your rules and targets. Any questions so far, Steve? It's been a lot.
Yeah. No, that's pretty cool. Actually, really stupid ass question. You said you downloaded the dashboard, right?
Hmm.
Did I miss that? Where do you download?
Yeah, so you have right here, you can, there's this create button, and you can create folders, and you can import, you can create your own dashboard. So if I just want to start from scratch, I can do that. I can add an empty panel. I can add panels from libraries. So you can filter by type. So gauge, I don't know, am I American?
Gauge?
Heat map,
Gauge.
histogram, logs, and there's this plugin list too, which is the craziest thing. Some of these. So alert list, bar chart, bar gauge. There's one of my favorite ones that I did for, I don't know if it's here. There was one plugin where you could create a PDF of your system or create like a draw.io diagram, and you could map colors and metrics into the draw.io diagram. So like, let's say you had, a Kubernetes cluster and it was 3 control planes and 8 workers, and then you had a couple databases that the workers were going for data, right? What I did was I created a draw.io diagram of the whole server setup, right? Mapped the CPU, memory, and file system usage into each part. And then you can set metrics to say, is it red, green, yellow, and for what nodes? And so you could see, are the workloads being distributed evenly? What you could actually do too is I would look at the network IO between the storage and the workers, and it would tell you, okay, you could see what database is being used the most. And you could tell, like, sometimes people would come and say, hey, like, can we speed this up? It's like, no, I can't get any faster read writes into that database. You are literally maxing out. So it would tell you visually that's where the bottleneck is. And you could display it as a non-editable dashboard to everybody else, which is what's great too. So when you kind of manage these dashboards, you can specifically create like a second user to come in and say, hey, I want you, like, if you sign in with this user and password, you can only see the cluster monitoring for Kubernetes, and it's only this specific dashboard. So really useful if you want to kind of say, hey, here's your system. This is what's going on. And realistically, if you were monitoring your DevOps and you had a bunch of other teams, you'd probably have a dashboard for each team. You'd probably have something that's facing them that is read-only, and then you'd have something that they can kind of like play around with if they wanted to. And you would have, some sort of cadence where every Tuesday you meet with every team and you say, are we good with the metrics? Is there anything you want to need? Is there anything that you want to talk about? Anything shifting? And that's just a good way to get input, file it as an issue, right? Let's say somebody wants, hey, I want to get C-advisor metrics, or I need to know what the read write is. They go and open an issue. You can literally change just the JSON code if you really wanted to. I would do it that way. And then just git push. And if you had some sort of pipeline set up, it would automatically update your VM, right? Like if you had, like, let's say you had Grafana and this is in a VM, and you had Ansible, for example, and you just needed to update that file. Literally, it would just be an update config file and restart service, right? So nice. Yeah, it's pretty cool that you can set up some really crazy workflows with it. There is Grafana Cloud too. So you can, instead of doing that, you can pay for the service where when you save dashboards, it just gets pushed into the cloud and you can just pull dashboards directly from there. It's another option, but it is a very, very useful tool. And there's just so many integrations that it will probably work with almost anything. One of the things I haven't touched on was the alert rules. So you actually don't need Grafana to set up alert rules based on metrics. You can configure alerts directly in Prometheus. I haven't installed Alert Manager here, but you could say, let's say I create a graph and I want to look at, CPU, node CPU total, and we'll look at that. And I sort by it and I say, if it's a specific amount of CPU, fire off a metric or fire off an alert. I can take those alerts, because those alerts are also written in YAML, and I can save them, and I can do it directly from here instead of doing it in Grafana. And I do know some people that would like it in Prometheus beforehand, because Grafana actually needs to pull from Prometheus and then hit the threshold, and then we'll send the message back to Alert Manager. It depends on how you configure it, but it can get slow. That was actually one of the biggest feedbacks when people were using Azure. And if you think about like Azure's UI, when it was scraping clusters for all the metrics, it does it in batch, right? It doesn't do it every 5-10 seconds. That would take up a lot of bandwidth. So it will just go every 2 minutes. Hey, here's all the metrics, and then run all the calculations against it. And that's the difference between an alert firing, 3 minutes, 5 minutes earlier and not, right? So there's a lot here that you can set up. You can also set up different dashboards to pull at specific seconds. So there's the dashboard refresh, but then you can also, if I'm in the cluster and I want to look at the memory usage, I can tell it how many steps, if I want to set alerts. It's like, how often are we going to look at the CPU usage? And realistically, like, this is kind of on, it's on your teams to be able to figure out and triage what's useful or not, right? Like, do you really necessarily care that CPU is at 90%? If CPU is at 90% consistently and you're not auto scaling, like let's say you have auto scaling set up and the CPU is at 90% for greater than 15 minutes and a node should kick in, then you need to alert on that, right? It's like, why isn't auto scaling working? So there's a lot there to use. And honestly, it could be a full-time job for somebody to take care of Prometheus and Grafana for let's say a big customer. I think any team that's bigger than like 3 or 4 teams, you're probably going to need 1 or 2 people on this pretty much full time.
Like Istio.
Pretty much. Yeah. And I mean, it is kind of the charm of cloud services, right? Like, you don't have to do this setup. They give you sort of those bare minimum metrics, and then you can configure from there. But they give you those defaults. And when you're starting to set this up and you have, hey, do I want to run in a VM? Do I want to do this? There's architecture changes. It takes a lot of time. So just the downside of it all, really the biggest advantage is getting everything in terms of the dashboard and the setup as code that you can just recreate anywhere you go. Because if Grafana goes down, all I need to do is just I can bring up the exact same dashboard, point it to the exact same spot, just with that JSON file. So it's a huge time saver to manage monitoring like that.
Actually, I guess the takeaway I had from this was that, yes, it could be a full-time job because it can do so much, but you can get something out of it in no time at all.
Yeah.
So that's cool. Low barrier to entry.
Mm-hmm. And there's a ton of write-ups that will help you walk through this too. The architecture can get a little complicated, but it's very useful for getting minimum metrics. I actually need to throw some workloads on here, so I'm gonna throw a big workload, probably like Istio, and we'll see what the sidecar architecture brings us. Yeah, this is a beast server. That'll be
part of our head-to-head. We'll have the Prometheus running on my Linkerd versus your Istio.
The other interesting way to go about it too is, if you have control over the virtual machines, you run node exporter inside every virtual machine. So like as part of the disk image, you have node exporter set up and pre-configured. And then when you create a VM and you pull that IP, it just gets slotted in. And the reason that you do that is because you can measure it at the bare metal level, and then you can measure it at the virtual machine level. So you can compare and contrast, and you can see what your overhead is between the two, which is pretty cool when you set it up that way. If you ever just want to play around, I would never recommend that, but it's you can basically, I can run node exporter on bare metal and then node exporter in all my VMs and set up metrics to compare and contrast when that workload's coming in to see what the overhead between the hypervisor is.
Nice.
Mm-hmm. And one of my favorite things too about node exporter is the disk space and the networking aspect. Because this, at the bare metal level, specifically if you only have, like I only have, 1 cable in to each node, I can tell when something eBPF exporter. I have not tried that, but I just saw that the other day when I was doing a little bit of research. So it would be pretty cool to see what I can swing with that. Yeah, bare minimum stuff, and there's so many different dashboards up there. There's cost dashboards. There's like AWS cost saving ones. So you just let's see if I can.
So what's eBP, just while you're clicking through there, what's the eBPF exporter doing? Is it like Loki for eBPF or something? Or
so the exporter will just take eBPF networking metrics and then expose them on an HTTP port to be scraped by Prometheus, right?
Oh.
Or something else. And that's the point, is like any exporter that formats anything in JSON like that just needs to basically expose JSON specific metrics on a HTTPS port, however you configure it, to be scraped by Prometheus, right? And then it's up to you to go into Grafana and figure out how you want to visualize these things. But you can use any exporter. I have Node exporter because it's the most common. The Prometheus install into Kubernetes that I've set up just literally scrapes like the API server and kube state metrics. Kube state metrics is the internal one that you'd run like kubectl top to get, kubectl top. The yeah, and there's, so if I wanted to go to Grafana, where are these dashboards?
I think it's just /dashboards.
There it is. Yeah,
it
is. Yeah, so there's a ton in here, and you can say I'm like AWS. Yeah, CloudWatch metrics, auto scaling, AWS billing.
Yeah,
look at all those downloads. Yeah. So yeah, there's a ton of stuff here, and I'd always kind of recommend using this as like a baseline. You know, people have been setting up these dashboards, pull a dashboard, see if the metrics work. If they don't, sometimes it has to do with just the targets that you set up. Because one of the other things too with Prometheus is when you set up these targets, you can actually configure, you can add keys and you can add key value pairs into it. So like, let's say I go, hey, I want to scrape Node exporter, but it's Node exporter for a specific VM that I want to monitor. You can inject some information in there if you want. It's so the Node X or the Prometheus scraping and the targets are pretty useful when you're setting them up. You might want to inject some extra information in here, but really, like, this is just super important when you're trying to search and run equations.
Very good.
Yeah, I'm pretty sure. Yeah, that makes sense. Yeah, you can see last scrape too.
Very cool. I like it. Yeah, we just had the Scorpio put the Cloudflare as a oh, and I thought I was wearing my Cloudflare t-shirt today. I'm not. It was yesterday. They made the BPF exporter, so that's cool. You can check that out. I'm just wondering if so off the back of that, my brain flipping back to security applications. I saw a lot of vital ops, which is, you know, obviously a big crossover into security when you're talking about resiliency. But are there like obvious security applications for the Prometheus Grafana combination that
in terms of setup, that is definitely not a secure setup that I just did.
That's not what I meant,
okay.
But also a good point.
Yeah, you can set up everything through HTTPS, for example. And there's a couple other things when you're setting up your data sources that you're going to want to look at. In terms of the metrics, I would say when you're looking at Kubernetes, you can look at containers and you can also look at read-write, and I would look at file system usage. So with the containers, you can look at specific file systems if they're being written to. And that's, you might want to say, hey, I just want a file system dashboard that tells me everything on all nodes and who's writing to what at what time. That's a pretty good one. Realistically, if it's if your applications are stateless, then you don't have to worry. And most people, when they're running databases in Kubernetes, you're going to kind of want to section a node off anyways. I really don't know that many people that just let every single workload run on the same node that their databases are running on. You're going to use some sort of key value pair label and node selector to make sure, hey, like these 5 nodes are for our Elastic cluster, right? And if that's the case, then maybe when you're running Grafana and Prometheus, you're monitoring those 5 nodes for specific read writes, and Elastic should only be writing to this specific section of the disk. Right. Everything else is like, raise a flag, right? Somebody else is doing something on the node that's not there. Yeah, you could set that up pretty easily. That's why the conversation between monitoring and the teams and how they configure the nodes is so important.
Right.
And it's also why infrastructure as code is so good, because as a DevOps person, I might not even need to go to the Elastic team to ask them and say, hey, have you set it up? I just go look at their setup in Terraform or Ansible or something like that and say, I see what you're doing here, right?
Yeah, because that always matches what's in runtime.
Yeah, that's that fair criticism. Yeah. True.
All right, cool.
But, yeah. And the other big thing is network. If you can just monitor network traffic, and you saw like network in and out at the host level is pretty important, especially like if you have no workloads running on it, or it's not something that should be accessed publicly and it tends to be only used, let's say, internally in a private network. And all of a sudden you see it's getting gigabit downloads at night. Like, what's going on here, right?
That's cool. Yeah.
Anyways, that's the other, my two off the top of my head, real good use cases. Anything else? Yeah, a ton of comments in here.
See as this came up, somebody mentioned the eBPF exporter. I brought it up, and because we've double hit lots of things today. In the references for the eBPF exporter, talking about creating custom metrics using eBPF from the kernel, which sounds really awesome. Hey, look, reading material. Brendan Gregg. There he is. The guy who Sun Microsystems tried to sell his own software back to him. So he's everywhere. He's the man for eBPF. So that's cool.
For sure.
Right. There we go. That was awesome. Thanks. That was a great demo. I learned a lot because, as I said before we started this, I have my Prometheus Grafana blank at the moment, a fresh install, and I am itching to download dashboards because I'm lazy.
It gets pretty fun. Some of the plugins are cool. So see some, nothing better than like a beautiful dashboard. No, like when it's just
a beautiful thing. Okay, we're learning about you.
Yeah. Cool. All right, that's all I had. Thanks for watching, because this is like the longest show we had.
Yeah, it is good. And thanks for sticking with us, Scorpio, and your contributions. Who you also just said, I tried to put up there, I double clicked it. There's a SNCC exporter, so there we go. That's pretty cool. That's it. Security teams getting on board with making their things available on Prometheus is pretty awesome.
It's awesome for getting Kubernetes information. You come into these big companies, they have, hey, we've been doing it this way for 5 years. You need to plug in with our specific app. It's like, okay, here's JSON. Go.
Yeah.
Right.
Yeah, I like it.
Awesome.
All right, we're done. I think that's the end. Yeah, you're right. 1 hour and 13. Our list of links was short.
Yeah, it's just,
but that was
what happens when I have 2 cups of coffee in the morning.
Yeah. They let you loose with a demo. All right. Awesome. All right. Well, I guess we'll sign off.
Yeah. Thanks for joining. Like and share. Also roast me if I miss something in Prometheus and Grafana. There's so much there. We're still learning too. Yeah. Thanks for joining. Have a good weekend. I'm Mike Foster.
I'm Steve Jaguar.